Welcome to David Alexander Maths Tuition. This is chapter 1b on algebraic fractions. So the good news is this is one of the easier chapters in the year 13 course. In fact, a lot of this is just going back to GCSE maths really. So here we're multiplying some algebraic fractions. So hopefully you remember that with fractions, when we're multiplying, multiply the tops, multiply the bottoms. So what we have is xz over yx. And we've got an x on the top and the bottom, so they cancel out, just leaving us with z over y. Now, I get a little bit frustrated with the students that I tutor that do what I've just shown you then. A lot of students don't appreciate or are slow to recognise that when you're multiplying, you can do the simplifying before you multiply the fractions. So we've got an x on the top here and an x on the bottom there, so therefore these can be cancelled straight away, leaving us just with z over y. So much easier if you do the simplifying before you do the multiplication. So for the second example, b squared over z times z over b, the z's cancel. We've got one b on the bottom, two b's on the top, so this b will cancel with one of the b's in the b squared, leaving me just with a b. Okay, so with division, we just need to remember that we turn it into multiplication and flip the fraction. Hopefully we don't need to start thinking about KFC at A level anymore. And again, simplify if possible. So C on the top, C on the bottom will cancel, leaving E over D. Second example, f squared over g divided by f over g is the same as multiplying by g over f. We've got a g on the bottom and the top, they'll cancel. This f will cancel with one of the two f's here, leaving just f. Okay, so with other algebraic fractions, we need to recognise things like factorising and the difference of two squares. So here we have x plus 5 multiplied by 7 over, now x squared minus 25 factorises to x plus 5, x take away 5, and that's really handy because this x plus 5 will cancel with this x plus 5. Now, a lot of people don't like multiplying fractions when one of the things is not a fraction. Well, remember that x plus 5, you can write that as x plus 5 over 1. If that helps you, remember that this x plus 5 is a numerator, so that will cancel with the x plus 5, and that will leave us with 7 over x minus 5, which we can put it in a bracket if you want. Okay, so this next example, x squared minus 49, you should automatically be considering that that is x plus 7x take away 7, and we're multiplying by x take 2, x plus 2. Now, presumably, we're going to end up with some x plus or minus 7s on the bottom or some x plus or minus 2s on the bottom so that we get some cancelling. Well, we've got an x plus 7 here straight away. So we can see straight away that will cancel with that x plus 7. X squared plus 7x plus 10, that factorises to x plus 5, x plus 2. And that x plus 2 will cancel with this x plus 2, leaving us with x minus 7, x take away 2 all over x plus 5. You could expand the top to x squared minus 9x plus 14, but I think it's probably more common just to leave it factorised as x minus 7, x minus 2. Okay, so here's another example, except this is division. So first of all, we just need to remember that we need to flip it. So x plus 3 over x squared take 2x take away 8 multiplied by x take 4 x squared minus 9, well, we need to remember that is x plus 3, x minus 3, and that's handy because the x plus 3 here cancels that x plus 3. And given that this is an x minus 4, I'm expecting the x squared minus 2x minus 8 to factorise to x minus 4 and x minus something. Well, let's just take a look at that. So we've got a 1 on the top here. So that's going to be, let's try, so factors of 8 that give us negative 2 is 4 and 2. So it's x minus 4, x plus 2 multiplied by x minus 4 over x take 3. And as I expected, the x minus 4's cancel, and that leaves us with 1 over x plus 2, x take 3. Again, I just leave it in brackets there. Okay, here's one final example, bit of a nasty one. We need to show that these algebraic fractions can be written as 2.5x squared plus 6x plus 2. So straight away we need to remember that dividing by this fraction means we are multiplying by 2x squared plus 7x plus 6 over x take away 1. Okay, so I can get rid of all of that. Now I'm going to factorise the easy bits first. So 4x plus 6, that is 2 lots of 2x plus 3. The reason I'm doing the easy stuff first is because this might help unlock the nastier bits to factorise. Now a 5x squared, that can only be done by multiplying a 5x and an x, and a 2x squared, the only way to do that is a 2x and an x. What I mean is if it was say 4x squared, then that could be 4x and x or 2x and 2x, but with a 2x squared it can only be 2x and x, and a 5x squared can only be 5x and x. Now I'm going to take a gamble. What we're expecting here is, because this is turning into a nice-ish quadratic, I mean it's fairly nice, a bit weird, we've got a 2.5 there, we're going to get some cancelling top and bottom. So I reckon that this 2x will be a 2x plus 3. I also reckon that either this bracket here on the left or this bracket on the right will be the x minus 1, and we'll be able to cancel. Now if this is 2x plus 3, if I'm getting a plus 6 on the end, then this must be an x plus 2, because that will give me my plus 6. Let's double check. I've definitely got 2x squared. In the inside I've got 3x, on the outside I've got 4x, and that gives me the 7x. So that is perfect. So a bit of a shortcut there. So this 2x plus 3 will cancel with this 2x plus 3. Now since this is an x plus 2 and not an x minus 1, let's gamble that this is an x minus 1, which means if I'm aiming for a negative 2, then this must be a plus 2. 5x squared, we've got minus 2, we've got. Now in the inside we've got positive 2x, and on the outside we've got minus 5x, 2x, take away 5x is minus 3x, so it definitely works. Now there's no guarantee that this, it's not a method I'm showing you, it's just a bit of a sort of cowboy way to try and guess without actually having to think hard about the factorising. You may need to think hard about the factorising in case if what I'm doing doesn't work out. Now this x minus 1 cancels with this x minus 1, so what we end up with is 5x plus 2 lots of x plus 2 all over 2, and on the top that's going to be 5x squared plus 2x plus 10x, so plus 12x plus 4 all over 2, and that is the same as 2.5x squared rather plus 6x plus 2. There we go. So we have shown that the f of x is the 2.5x squared plus 6x plus 2, and we are done.